Okay, students. So today we will see the ER model in database management system. Entity relationship model is kind of the data model as we have seen the previous class. In the previous class, what we have seen, just let me just revise you once again. In the previous class, we have seen what is mean by the data models and what are the various types of data models. So we have seen the network model, hierarchical model, ER model, and one more, that is a relational data model. So overall study of the uh, data models, we found relation model is more important, and thereafter we have entity relation model. So finally, what we have the outcome for representing your data in the graphical way or pictorial representation or depiction you have, then you can represent the ER model. But after understanding this point, if you need to represent your data in a tabular manner, then you must have the relation model. So in our database management system, when we do any practical aspect, when we follow the practical aspect in a normal way on the real life situation, year model and relation model are more important. But when we're talking about any industry, so any based on any industry, our network is expanded into the different way. That could be the network model or hierarchical model. So as a student life, we are doing any small project, then we will consider this would be the part of the our relational data model. That's enough. But if we need to look for the our great project, or we can say the big project, at a time our data model can be expanded into the form of the network model as well as the hierarchical model, depend on the industry demand. So we can't say here this network model and hierarchical model is not useful, but uh, having seen the current scenario, they are not much useful. But depend on the situation, depend on the problem, depend on the circumstances, or depend on the needs of the industry, it can be expanded. So having seen this point, today we will see the ER model in detail way, because our ER model is just like the flow chart in the our programming logic concept. So we will see the everything with our ER model. So as the name suggests, we have the two words, entity and relationship. So entity, as we know what is entity, and today we will see the what is real entity. So with the help of the various example, we will see the every concept in detail manner. Okay, this is the slide I can skip over here because the student asked me the question, sir, what is the data independence? So for the revised purpose, I've explained. So if you have any doubts, then I can explain, else we can skip this part right now. So data independence, we have seen in detail manner, logical data independence and physical data independence. So as these are the two type of the data independence we have discussed. So this is the summary, I put it over here while discussing the thing. So as a student demand, so and the time to time we can revise the any topic in between. So as student asked me, so that's why I have put it over here. So I'm skipping this slide over here. So I'm moving to the next part that is more important. What is an entity relationship diagram? That is a point. Entity relationship diagram is known as in shorthand way ERD. ERD stands for the entity relationship diagram. So what we can say, what is the ER diagram or what is the ER point? So ER diagram, so actually what happened in the ER model, entity relationship data model, we will represent our information in form of the entity relationship diagram. While in the case of the relational model, we will represent our information in the form of the table manner, only nothing else. So as the name suggests, entity relationship diagram, it shows the relationship among the entity sets. So please remember, we have already discussed this point. So an entity set is a group of the small entities, and these entities can have the attributes just like the student. So what are the student attributes of student properties? Name, roll number, class, semester, year, hostel number, okay, room number, and in which subject, in what is the course he was registered. There are so many attributes. So same things we have to understand. This is the real world entity as a faculty. So what is the entity? What are the properties of the faculty? Properties of the faculties could be the faculty name, faculty number, faculty employees ID number, in which the faculty was appointed, and what is the date of joining of the faculty, and what is the where is the cabin number of the faculty. So there are so many attributes we can find in real life situation. So in terms of the database management system, an entity is at nothing which is just tabular information we have or along with the attributes. and this table is known as the our relation or database in the our database management system. So if you are writing, you are seeing a word entity set, as the name suggests, entity set. Entity set is nothing which is a collection of the various entities. So unlike flowchart, we can see the ER model. In ER model, we are not bound by the single entity. We can have the many entity sets. So I'm plotting the entity relationship model of the university. Suppose it. So in an university ER diagram I'm preparing. So what happened? I have the various entities. What are those? Student, student itself is an entity. Faculty again itself is an entity. Staff itself is an entity. Room itself is an entity. Lab itself is an entity. So whatever the entities we are putting in the university DIAD model, so these are known as the various entities. So an ER diagram is composed by the many entities set, many entities, and that is known as the entity sets. Mathematically, I can speak over here. So as you can see, I have already written over here. So E is our entity set. So E1, E2, En, small E1, small E2, and so on. So small En are the various entities. So E is a set of these entities. Then we have the entity set. So capital E becomes the entity set. This is only just nothing, only meaning. So this is the point you people are required to understand properly. So this is the basic term. This slide is clear to all right now. Is it clear to all right now? This slide in concept what I am discussing. What is the entity set and what is the ER diagram? Is it clear to all right now?
Yes, sir.
Yes.
Okay, so everything is written in the my PPT. This is the summarized concept. So when you just turn on the various pages on the books, it is a better idea to look at the my slide where everything you will find in the concise way. That is a great point we will see in the class. So I request to all those students many times just attend the class on the time. So everything will be clear while understanding in the class. That is the reason only for attending the class. Now entity we can say, and in the relational algebra we have the name relation, and the normal way we have to speak the table. So entity, table, relation are the only naming convention, nothing else. Room. So a student asks me, sir, what is the room at properties could be or attribute could be? Yes, simple. Room ID, room name, room size, and in which floor the room is also available. So room ID could be the room number, we can say. Room name, we can say the room name. I'm putting the A block 305. So 305 is the 305 is what? Room number, and A is representing the, that is the in which block we have. So room name we can write the combination of the floor number as well as the room number. So room name could be the A305 and room ID will be the 305. And room size, okay, it is a hall, it is a lab room, okay, it is a lab room, it is a hall room, or it is a only the conference room, so we can say. So these are the various kind of things we can represent. So entities in a real life situation we have to understand in the form of the table. So that is the point. In the relational model, these entities are transformed into the table form. That is the point you have to understand. And attributes would be the column name or field name of our table. That is the point you have to understand. And relationship would be the one to one, one to many to one, and many to many. So what is the relationship between the two different entities? That is the point you have to understand. So this is the point from where we have to start the ER model in more depth. So far we have discussed its preface, or we can say we have seen the overview of the ER model. So now let us move to the next slide, and which describe the many things. So in this slide, as so far what we have discussed, there's some summary. As I'm speaking once again to all, ER model is composed by the various components. So what are the components? Entity, attribute, and relationship. So please keep in mind in the examination or at the time of the interview, if anyone asks you a question, what is the various component of the ER model? Definitely you can easily say, sir, entity, attribute, and relationship are the component of the entity relationship diagram model. So what is entity? Entity is a real world entities. Okay, that is a real world object, you can say. In our relational database model, we can say it is known as a table, and relational it is known as the relation, but only naming convention, nothing else. Example, you can see over the my screen, I have already written student, faculty, room, etc. Okay, table itself becomes an entity, chair itself becomes an entity, Okay, so there are many things by which you can represent the thing. Next one, we have an attribute. So attribute, what that is a property of a table. What is the properties? It could be one property, it could be the many properties. So faculty is our name of the entity. So what is its attributes? Faculty ID, faculty name, age, date of joining, salary, in which school, and others are. I'm taking another example over here. Suppose I'm taking the room. So room is our table, a room is our entity. So what is its attributes? Room ID, room name, okay, and in which floor the room is available, and what is the type of the room, okay, size of the room we can say. So whatever we have in our life, that is becomes as an entity, and we can have the various properties of each and every entity in this world. So that's why the database management system is subject which is associated with the real life situation or real life problem based. If you are following any study by the real life concept, definitely, and I'm pretty sure you will learn the thing in the detailed manner as well as the conceptual. So rather than the vocation, just try to connect your any subject with the real life problem. Definitely, you will easily understand the concept in summarized way. Now, come to the point. Next, third component, a relationship. So, relationship is just describe the connections between the two different tables or two different entities, just like the student faculties. So, what is the relationship? Course. Course is the relationship on which the student are connected to the faculty. Before teaching to this course, I was not connected to you. I was not your teacher, and there was no communication between you and me. So, what is the connection between you and me now? So, what is the relationship between you and me now? Course. So, CSE 3001 I am sharing to all, and now I am offering this course. Now you are opting me. So, now we have the connection based on the our important relationship. What is the name? Course name. That is the only meaning. And it could be the various type, that is the one to one, one to many to many, and many to one. Just like a simple example. A student can opt the only single course. So this is what one to one only. A student can take the admission in any university in the one course only. So what is this? So admission is a relationship, and student and the course become the two different entities. So what is the admission? Admission becomes the relationship. Many a faculty can use the many student, that is a one to many, one to many. I am speaking the active statement or English statement. I can speak many when faculty is teaching to the many student, that is the one to many. Reverse, I can speak in the passive format. Okay, active English statement I can speak in the passive format. I can say many students are taught by one faculty. So this is the way of the study, or this is the way of the reading the statement from which direction you are reading. So if I'm reading from the left to right, or if I'm reading from the right to left, so sense we are having the same sense. So one to many, many to one, we have the same sense. Many to many. Many students can occupy the many seats. Suppose there is an open theater, and students are coming to see the or watch the movie in a theater or hall, or any cinema hall, I can say. So no a seat allotment I am giving. Now you are free to choose any seats, whatever you want to choose. You can opt the many seats. It's your choice. So many students or many person can opt the many seats. So that is a one to many relationship. So that is the point we can observe over here. So here we have the relationship type. So in an ER model, in your diagram, we have the many entities. So there are represented by the E1 to En. So that is a set of the entity, and that is known as the entity sets. Okay, so now this example is clear. What is the component and what are the real life problems we are having, and how we can represent the thing so far? Is it clear?
Yes, sir.
Are any doubts so far you have? So please you can ask me anytime, because this is the fundamental points you can't skip. Once you skip, nothing you will able to understand, and definitely you will not able to write your own ER model with the proper justification. So please understand the thing.
Sir,
So yeah, understand me.
sir, it was written that in entity sets, these are basically collections of similar kind of entities. So, sir, what are similar kinds? Like,
Where it is written similar kind of.
so in the previous slide where entity sets was written.
Yes, similar entities means entity set is group of the similar entities means it should have the some meaning. Similar entities means uh, there should be a relationship between the two different entities. If you are making suppose student faculty, so student and faculty should be become part of an industry. And what is the relationship between the faculty and product? That is the meaning only. One entity becomes the product manufacturing or marketing department. And what is the relationship between the faculty and marketing department? There will be no sense. So that's why the written means the group of similar entities means the entity should be meaningful. So the association or the connection we can establish in easy manner. That is the meaning.
So the like student and faculty can come into one entity set.
No, yeah, definitely. So in the one entity set, yeah, definitely it should be. So because having seen the one entity set, you can design the ER model properly. So there will be some relationship between the student faculty. But if you want to write the another entity set which belong to the marketing, suppose. So in the marketing department, we can have the products and the selling department and other department we can also put. So there will be no connection. There is no required. We can make if it is required, then we can make. It is also possible. We can make, but there is no need. So what is the relationship between the student and marketing department? What is the relationship? There will be no sense. So definitely we can put the our similar type of the entity means we can put the our related entities only. Similar type means we are talking about the related information, related entities we can put. That was a
Okay, sir.
okay. So after understanding this point, let us move to the this diagram. So far, I have not discussed the notations, so I am just explaining the basic examples over here. For clarifying the my idea, what I have. So student is an entity. I am giving its instituent name that is a E1. So E1 is a whatever first entity. E2 in the example you are not required to show, but for explaining purpose, I am just giving here information only. So student entity that is E1 I am having small E1 you can put. I am putting the capital E1 doesn't mean. Now E2 I am putting the second entity that is the two entities we have. One is faculty and the one is a student. So these two entities can make the communications. How it is possible? What is the name of the relation on which they can communicate? That is a course. Okay. A husband and wife are connected to each other, but what is the relationship between their and husband and wife? There is a marriage. It is just like the simple things. The relationship should have the name. So what is the relationship between the husband and wife? Because both are the married. Definitely we have this point. So that will, inspired from this story, we can say the student and faculty can be connected by the some relationship. So what is the name of the relationship? That is a one. That is a course, or maybe the any other thing. Suppose a student may connect to the staff. How it is possible? Sir, while discussing the admission time, I have communicated to the some person. Those are the not faculty; they are the staff of the university. So how many staffs are dealt with the many students? So student and staff can also communicate based on the admission. So admission becomes the relationship name. Now this is a real problem I'm discussing. Yes, it is possible. If many students are taught by the one faculty, so we have the many to one relationship. Depend on the from which direction you are reading. And what are the attribute of the our student? Student number, name, and course I'm keeping over here. And what is the faculty attributes we have? Employee ID, faculty name, and course. So course is the one important common attribute by which they can make the communication. That is the point you have to understand. So this is a simple and just example I am taking. So in this diagram, you are observing diamond symbol are used to represent the relation. Faculty and student are the entities, so those are represented by the rectangle. And I'm using the ellipse symbol for representing the not ellipse symbols to represent the attributes or our properties of the entities. So these are the three basic notation, and the rest of the notation we will discuss. But this is the example of the first ER diagram as we are discussing today. So entity set of the ER model how it becomes the E1 and entity E2. So mathematically I can draw the my concept like this one. So what is the entity set? You can write the E1 and E2. So what is E1? Student and faculty. This is entity set. So what is the relationship set? Unlike the entity set, we can also have the many relationship in the our ER model, and those can be identified by the relationship set. Relationship set is nothing which is the collection of set of the many relationship what we have in our ER diagram. So in an ER diagram, there is no guarantee one entity or one relationship will be there. There are many possible chance we can have the many entities and many relationship. That is the point. So we have entity set and relationship set. Now this diagram is clear.
Yes, sir.
Okay. So what was discussing? What was discussing? And now we were on our important point component. As I told you many times, and I'm speaking once again over here, these are the three components: entity, attribute, and relationship are the component of the ER model, as we have discussed. So entity, a real world entity, anything, just like the example, teacher, student, course, building, department, in any university. In any university or any college, the teacher, student, course, building, department becomes our entity. That is the only one. Attributes. Attributes, you can take the teachers or faculty. So what is attribute of the teacher or faculty? Teacher ID, faculty ID. I can take age, salary, date of joining, in which school he or she belong. Relationship type. A relationship type define the relationship between the two different entities. So teacher works for a department. So department is a different entity and teacher is a different entity. So what is the relationship on which they can communicate? Yes, of course, based on the work or their joining. So teacher works for a department. So teachers become the one entity and department become the second entity. So they are communicating to each other based on their joining the department. So if it is the simple things by which we can use the our three important components of the ER model, that is the entity, attributes, and relationship. I am not going through the unnecessary theory, but I am explaining the idea with help of simple example over here. Okay, now it is clear to right now. We have already discussed many times, so I am not going through unnecessary theory, but I am taking the examples only. Is it clear to all right now?
Yes, sir.
Mobile could be your entity. So that is a mobile IMI number. Okay, we can say that it's a sequence number. And battery, what is the battery number I'm using? So that is a mobile. Mobile has its own identity. So unique number. In this world, we have each and every mobile that is unique. So that is IMI number. And what is the cost price of the mobile? What is the brand we are using? I can use a mobile Apple, Samsung, and Motorola, and various company. And what is the model? Because each and every company has a many models of the mobile. So these are the various properties attribute by which I can define this is the mobile real world entity we have. So this could be the attributes. Attributes means I'm talking about the properties by which the identification, the entity can be identified. The entity can have the one attribute or many attributes. So there is no restriction. This is the problem I have a design over here based on a relationship type. While discussing this point, a student asked me question, so I'm sharing this PPT over here. I didn't remove. Okay, I always keep my discussed slide every time. How many times I'm discussing doesn't mean I always keep my discussed point to the students so they can take the advantages. So based on the request of the student, I have designed another ER diagram. So that is the teacher, there is one entity, and another entity becomes a department. So department, we have a department ID, department name, and course. And teacher ID, I've given the teacher ID, department ID, he was joined. That is a common attribute should be there. So we can make the relationship. Without the common attributes, how we can make the relationship? That is a common thing we can understand. And salary. And course, salary is and other thing. So relationship will be defined by the common attribute that is the department ID. So teacher works in a department. So in which department he is working? So in which department? So what is the property by which we can identify department name or department ID? That is the point. Okay, instead of the department ID, you can put the department name. Of course, you can also put the department name as a common attribute, no issue. So a teacher works in a department that is a one-to-one. A teacher works in a department that is a one-to-one. So I belong to the computer science department. So I'm working on a computer science department. So as a my individual identity, that is as a faculty, I'm joined on the one department that is a computer science department. Many teachers work in a department. Yes, of course, because in our school, in our department, we don't have a single faculty. We have many faculties. So all the faculties, those are belong to the computer science department. So what we have the relationship. So in our department, so many faculties are part of the our department. So we have the many to one relationship. A department can have the many teachers, so it is just only the reading the statement from the different way only, nothing else. So one to many relationship we have. So a department can have the many teachers, of course. So I am just writing the statement in the reverse manner. So we have the many to many or one to many, it doesn't mean. Next we have many teachers are associated with the many department. Now this is a question you must ask me right now, sir, how it is possible? Yes, as a computer science department, I am just belong to computer science department only. But I am handling the classes of the other students. Suppose I got a chance to teach the non-technical course to the other department students. So they are not a part of the computer science department, but they are a part of the different department. So in our course, suppose that in our course I am choosing a course that is non-technical, in which I have the various flavor of the student, just like the cybersecurity, BI students, MIM student, and cyber gaming students, and other department students as well. Suppose aerospace engineering students are coming here. So I am taking the mixed kind of the student. I am handling the mixed kind of students. So what is happening? Many faculty can teach many students. That is the one to many we can observe. So as a faculty, we are handling the many students. So unlike me, many faculty we have. So many faculties are handling the different kind of the students. So we have the one to many relationship, and that is only the point. So I am not associated with the at the time the computer science department. Now I am not handling only the BI students. I am handling the various flavor of the students, those who are not part of the computer science department. So non-computer science department, I'm also handling the some students. So this is what I'm associated with the some other students. So this is also possible, and this is really happening in the university. Now, so here what we are observed, we have seen the relationship type. So what is the relationship type? We can represent with the real life example. Now it is clear to all right now?
Yes.
Okay, so far I'm speaking once again. I didn't discuss the notations. I'm using the basic notation to give idea what is the actual ER diagram. Okay, after this point, this is just only theory portion, and which describe that the ER model captured the relationship between the real world entities, much like a network model, because just like a network model only. But it is not actual network model. It's just representing like the network model. But it is not directly tied to the physical structure to the database. Instead, it is often used to designing the database conceptually. So when we have to design the database conceptually, that is logical structure, then you will have a graphical tool, and that graphical tool is known as the ER model. ER model, okay, not ER model, that is ER model. So ER model, we have to understand, or we have to transform our ER model into the our actual database, and that is known as a mapping. That is a concept. That concept is known as the mapping ER model to the database, and that is the concept we will see after learning the ER model. So this is an important point you have to understand. So these are the two important theoretical portions you have to understand. So mapping is also required after designing the ER model. So it is just like equal to the after designing the flowchart, you will write the flowchart into the form of the algorithm. So this is what you are transforming your flowchart into the algorithm. That is the transformation or conversion you are required. Same thing, the ER model conversion is required into the form of the database, and database is actually physical information, that physical structure. While ER model is not a physical structure, that is a conceptual structure, or that is logical structure, we can say, that is plotted into the form of the graphical methodology. So here the many people are use the various advantage or various things by which they can represent the data into the database. So database is used to store the information only, but ER model is not used to store the information. Actual data will be stored into the databases only. So it is required to understand a mapping should be properly. And the word I'm speaking once again, as I told you previously, the cardinality or relationship we have the between the entities, that should be. So the name, it is naming convention only. Cardinality means we are talking about the relationship type. We have the same meaning, cardinality and relationship. But cardinality means we are talking about the what is the relationship type we have: one to many, and many to one. So that is the point you have to understand. This is another example I'm taking over here. As I already told you, so I'm not going to this point detail, but I'm speaking here only the concise way. A student is studying in a college. So a student is studying in a college. So student is we have one entity and college will be the one entity. So studying is what, that is the relationship name by which they can connect to each other. So what you are observing, what is the common thing by which they can communicate? So that is study in which class he or she belong. It was not mentioned in our ER model, but we have to use properly to justify the answer properly. So the relationship between the student college is many to one, as a college can have the many students. So from the left, right to left, you have to understand in college there are many students. Many students can be the part of the college, one college. Okay, but a student cannot be study in a many college. Is it not possible? You can't take the admission to university or to college simultaneously. So that is the point you have to understand. You have to think logically. So many students will be the part of the one college, or one college can have the many students. This is only the reading of the student from which direction you want to read. So here I am writing the a student is studying in a college. Many students can studying in a college. It is also possible. So many students are studying in a college. Of course, it is also possible. So at a time, the my relationship become the many to one. But here my written statement are saying to one to one only. This is only meaning only. So college ID will be the or college name will be the common attribute by which they can communicate. So all these are just showing the our arrow are showing these are the attributes: student ID, student name, student address, mobile, city, college ID, and college name, and all these are the attributes. Okay. So before describing the its basic notation, tell me right now. So far, everything is clear. The fundamental study is clear. What is the ER model? Is it clear to all? Because now it's time to see the our diagram or notations. Is it clear
Yes,
to all
sir.
right now? Yes, tell me right now. Any doubt so far?
No, sir.
Okay. I'm speaking once again. From this point, if you are skipping any statement, you will not able to solve based on ER model. So please listen carefully. Now, rectangle. Rectangle basically used to represent the entity set, and what is the notation? You can see on the right side I have the notation I have already mentioned, that is person could be the entity that is represented by the rectangle. So entity sets or one entity can be identified by the rectangle, that is you people are required to understand. And ellipse are used to draw the our attributes. So city would be the our ellipse. City would be the our attributes, as you can see, which is mapped by or which is directed by the arrow symbol. You can easily see. And diamonds are used to represent the and relationship set or one relationship we can have. So diamond is just over here. So as a student faculty, students are opting the course. So course opting becomes the our relationship. So this is the point you have to understand. Lines. Lines are used to link between the entity and relationship, or one to one, or relationship to entity, how we can communicate. So one symbol is required, that is a line only. So the link between the or link attribute or link between the attributes or the entity to relationship we have to use. So these are the four important attributes. Now, is it clear to all right now, or anything you need to ask? Tell me right now. Thereafter, I will move to the next point. But before that, you have any doubt, so you can ask. So far, any doubt? Please, you can ask me right now. Yes, student, tell me any doubt so far you have?
No, sir.
So what we are studying, I'm speaking once again, we are studying the symbol and notations to draw the ER model. So next we have the double ellipse. We have seen the one ellipse, but now we are using the double ellipse. So what is the meaning of the double ellipse? That is important. Because our information is not by the limited data or constrained data. We can use the our information, we can represent the information in detailed way. So double ellipse means we are talking about the multi-valued attributes. Now we have a question, and now the symbol is visible to all. So double ellipse will be used to draw the double ellipse, that is multi-valued attribute. Now, can anyone tell me what would be the example of the multi-valued attributes? Can anyone tell me the example of the multi-valued attributes?
Sir, address.
Yeah, address could be. So can you justify the answer? Could you explain?
So there could be a permanent address and a correspondence address.
Okay, I'm accepting this point. Yes, this is a good point. So when we have the
Sir,
yes, good answer. Yes,
sir,
tell me.
how about phone number? Like a
Yeah,
person can have multiple phone.
yeah, phone numbers. So multiple phone numbers could be. But suppose the phone number, I'm not having the multiple phone number. I have a one phone number only. Now what happened at that time? Multi-valued attribute. So now tell me, the example address is great example. Phone number can also be acceptable right now, no issue. The point you have to understand over here, when an attribute which contains the multiple values, then we can say. So a phone number could be. A phone number could be. Now, how it is possible? In a phone number, we have the country code. If you're talking about the landline code number, so we have the area code, we have the actual phone number. So when talking about the any contact number, if I need to communicate to the my friend who is staying in the outside the India, so first of what I have to use, I have to use the country number, and then I have to use the mobile number, and that is a different way. But if I'm calling on the landline number, so what we have, I have the country number, country code I have to use, I have to use the area code, and then I have to use the actual number. So this will be the part. So a phone number can be the great example to justify the it can be the multi-valued attribute. Okay, so address is also good example. In the address, we can have the permanent address or local address. We can also definitely this could be the one part because one attribute can have the many values. So we can have this is a great example. This is a good point. Now, dashed ellipse. Dashed ellipse is saying to the derived attributes. Now, what is a derived attribute? Can anyone tell me right now what is a derived attribute? All the example is already written into the my slide, but you can also explain the example in your terms, so it will be better. Just tell me.
So one which is derived from another attribute.
That is a technical term you are speaking. Just could you explain with the example?
Like here the age is written. So
Yeah, is it okay? Tell me.
age can depend if we name an attribute date of birth, then we can find the age from the date of birth. So it is derived from that attribute.
See, get an answer I'm getting here from your side because everything is written on the my slide. See, if I need to find the age of the person, so I will not need to write the age manually. What I will do, I will put the I will select the date of birth of the person. So after choosing the date of birth, it will find the internally with the internal code. It will find the gap between the current date to the selected date of birth date. So the gap we are finding that is a 30 year, 40 year could be. So the age we can calculate it automatically. So age is the our attribute that is calculated by the choosing the appropriate date of birth. So date of birth becomes is our one attribute and age becomes our another attribute. So age is derived on the date of birth attributes. When we have a dependency, so age is dependent on the our date of birth attribute. So at that time, age becomes the drive attribute. Now, is it clear to all right now? Is it clear?
Yes, sir.
Okay, good. Okay, so when we have the entity, so no issue. But in our database, there are some chance we can we can keep the store the duplicate record. Yes, of course, it's possible because there is no restriction. I can keep your name many times. I can keep your many times I can keep. But I'm doing the foolish work. But truly speaking, I'm increasing the unnecessary space. I'm just keeping your name one time, that's enough. Why I'm putting your name 10 times or 100 times? It means I'm having the redundancy in my database or duplicacy in my database. That is the point you have to understand. What I'm having the duplicacy, I'm having the redundancy in my database. So this is what I'm unnecessarily increasing the space. So space complexity unnecessarily increasing, there will be no sense. So what I will do, I will apply the key on the my table or entity. So that the time what key I'm using or my attribute I have to choose, that becomes my key attributes. So if I'm having the key attribute on the my real model or my database, I can say, so that can be followed by the primary key. Okay. So if I'm having the primary key, so the key, the attribute which are following by the key, then such attribute becomes the key attribute, and definitely we have the primary key, so no duplicacy will be there, and every record will be uniqueness. That is the only point. So in our entity set or entity, we don't have any key attributes, then such entity can be recognized by the big entity, and that can be drawn by the, or that can be depicted by the double rectangle symbol. That is the point you have to understand. Okay, is it clear to all right now? So far, where is the example? This is clear to all right now?
So is foreign key also a key attribute?
Foreign key will be the key attribute, no issue. You can take definitely. It could be the key attribute, of course. Yes, of course, we can.
Okay, sir.
But I suggest you, while designing the ER model, you are required to just display or show one key attribute by the one attribute only. Do not show the multiple key attributes. So definitely your diagram will not justify the answer. So whenever you need to discuss something through the ER model, just maximum you can take one key attribute one by the one entity, that is enough.
So, sir, if there is one foreign key and one primary key, then I should make the primary key the key attribute.
Yes, that is a great answer.
Okay, sir.
Because that is the key attribute of your such entity. So it is better idea to do not depict the point by that point. And when we have the key attributes, so what we have to do is we have to just underline inside the our ellipse. So in the ellipse we are putting the underline, that is the such attributes become the our key attributes and nothing else special. Now first, second, third, fourth, fifth, sixth, and seventh. Their components are clear to all. Now, notices are clear. Now, come to the point. Unlike, look at the diagram as well. Unlike the big entity, if we have a relationship by which we are making the relationship by the help of the big entity set. So we can also have the big relationship, and that can be identified by the double diamond symbol. So double diamond symbol describe the big relationship, and that is followed by the, we are following by the our relationship with the help of the big entity. So when we are creating or we are mapping the relationship by the big entity, so automatically your relationship will be becomes the big relationship. Now 8.1 is very interesting, and do not have any confusion over here, and that is very interesting point we have to understand. Double lines, when we have to use double lines, I'm just using double lines with help of the example I will show. Double lines describe the total participation. This symbol is known as the total participation. So this describes that at least one information will be part of this relation. It is like just example. I'm opening a university, but there's no student. So student and university, there will be the relationship I'm keeping, but I'm I'm expecting there is no student. But if I'm writing, if I'm using the double lines, then at least I'm described in a such university, in such college, at least one student exists. So if I need to describe explicitly, at least one student is available inside my university, so I can use the double line instead of the single line to draw the relationship between the entity and relationship or different entities. So that part I will show the by practical, theoretical, then the thing will be clear. But double line you have to understand. Double lines means I'm speaking the total participation. Total participation means at least one information will be exist. That is the point. Now, last we have a composite attribute. Composite attributes means describe that you are talking about the address. So we have the two type of the address, one permanent address, local address. So with help of the multi-value attribute, I have seen. No issue, I'm happy. But I found that is the address can be various part. Right? Address can have the many other attributes, and that attribute is known as the composite attribute, just like C. An address can be represented by the city, state, country, colony, an area, and so and so. So there are many components are available inside the our one attribute. A name can also have. A name can also have first name, last name, middle name. So when we have an attribute which is composed by the many sub attributes, then what happened? That is known as the composite attribute. Now clear right now? Is it clear to all right now?
Yes, sir. Yes,
Yeah,
sir.
super. Yes, good, great answer. I got it. Now, next. Okay. Any confusion or any doubt in these topics you have? So please let me know right now. The
Sir,
notation, just tell me.
sir, can you please explain weak entity again?
Your key attribute.
So weak entity.
Big entity is saying to us when we don't have any key attribute in our ER model. Suppose I'm having the entity, student entity, but my student roll number does not exist. I'm just explaining the this student entity by the student name and student class only. Suppose I'm using two attributes. So there are 100% chance a student name can be duplicate, and so some of the students who are having the same name are also opting the same course or same faculty. So definitely what we have the duplicate record. So it is not easy to rectify that is a duplicate record or we are having the different record. So how we can identify with help of the student roll number? There is a 100% true factor. There are two students who are having the same name, but how we can identify? We are confused at a time. Are we having the two different records or are we having the same record two times? So how we can distinguish that part? That is a student number, student roll number. So, but we don't have this attribute in our UAR model. So that entity by which we can represent that is known as the peak entity. So my dear student, just go in the teacher, in the teachers and department. So I'm not using department ID or teacher ID. So at the time my these entities becomes the weak entity, but if I'm using, so now this becomes a strong entity, or we can say the key which are the entity which are having the key attributes. So the entity which is having by the key attributes, that is known as a strong entity. The key which does not having the key attributes, that is known as the weak entity. That is the difference we have to understand.
Okay.
Okay. Okay.
Yes.
So all notation is clear to all?
Yes, sir.
Okay. So let us move to the step by step component of the ER model. So we have discussed. So this is a summary. Once again I'm giving, so in between the my slide everything you will find, I will put the summary in between to rectify the concept so far what we have discussed. So component of the ER model with the their subcomponents. Entity will be two types, weak entity and a strong entity. So weak entity means the entity which does not having the key attributes. The strong entity means the key attribute, the entity which is having by the key attribute. An attribute. What you are observed from our notations, we have the attributes, key attribute, now composite attribute, multi-valued attribute, and derived attribute. Have you seen all these attributes with the help of the notations? Tell me yes or no. Have you seen?
Yes, sir.
And relationship type we are discussing many times: one to one, one to many to one, and many to many. So this slide describes the summary part of our component what we have discussed along with the sub component. Now, yes, tell me right now. Any doubt so far, or you have any doubt? So you can ask me right now. Any doubt in any topic from this point? It is written over here, so you can ask me. Yes, you can move to the next part. Yes, tell me right now.
Sir,
Yes.
could you repeat double lines again?
Which one?
Double lines.
A double line. Double line, I will show the with the help of the example, but I'm speaking once again in the concise way. Double lines means a total participant. The name of this symbol is known as the total participation. Total participation, just like this one. Suppose I'm taking your real example, by which the concept will be clear. You want to opt a course. Okay. So in the interim semester, you got a chance to opt the 3 different courses. But so far, you didn't choose any subject. So it means there is no participation of you in the interim semester because you have not opted any courses so far. Am I right? Is it clear? Is it clear? So there is a relationship between the you and your intern semester. We are drawing, we are keeping this point. But you have not selected so far any subject due to some other reason. I don't know what was the reason you have not selected. But what is the reason you have not selected? That's your up to choice. But this is a time I'm giving you chance after the registration. Maybe some registration process you have not filled the properly. That could be another reason. But now you have done the all the process. Now you are choosing one subject at least. At least listen to my words. You are choosing at least one course. It doesn't mean you are selecting the all course or selected course. But at least one course you are selecting. So at least now you have become the part of the interim semester. I'm speaking once again. There was a relationship between the you and interim semester, but now at least you have chosen the one course to confirm that now you have become the part of the interim semester. At least you will study. You will study the one course. At least you will study the one course. So I am focusing the at least word again. That is the meaning over here means the total participation described at least student will study the one course. It doesn't mean he or she will study the 3 courses or 2 courses, but at least he will study the one course. So at a time, I will depict the relationship between the student course by the double line rather than the single line. That is the one. It is clear?
Yes, sir.
I'm taking another example for a betterment. Suppose in a room, I have constructed a new room over in my university. I got a chance, but there is no table and no chair in the room. So if I need to take the class inside the room, so how I can take the class because there is no chair and no table. So how the student can sit? That is my point. So if I need to take the class inside the room, but there is no chair and no table, so how we can take? So that is a means. The relationship between the faculty and room is also exist, no issue. But how I can take the class? So if I'm putting in the one chair inside the room, so at least I have the one chair. It doesn't mean 60 or 50 or 80 seats are available, but it doesn't mean the rooms are vacant. But I have at least one chair, so it means I can take the class. So the relationship will be the good when I have at least one chair. So at least one student will come. So the student can come to my class inside the room because at least one chair is available. But previously I don't have any chair inside the room, so that was a problem. So when we have the at least word we have to use, then we can say we are using the total participation. But while drawing the thing, there is no guarantee. We are expecting there is no guarantee. Or there is no data will pass. Relationship exists, but there is no data will pass. But when we are saying explicitly, at least one information will pass, so we have a total participation. Now, clear right now, or any doubts so far? Just tell me right now. Any doubts so far?
Sure.
Okay. So let us to discuss the entity once again. So having in this slide, now you will ask any doubts so far you have. So student M11 you can observe over here, that is put it over the line that depicts the relationship type what we have. If I'm reading the statement from the left to right, so I can read my statement. Many students are studying in a college. This is a one two, sorry, many to one. If I'm reading the statement from left to right, that is a one to many relationship will be there. So one college can have the many students. So that is an entity. Okay. So entities are depicted by the our rectangle. So it is showing this point. So slide by slide, I will ask. So tell me right now, any doubt so far you have? Any doubt in this slide?
No, sir.
Okay. Now, what is a big entity? Now, let us discuss more one more time the big entity. Now, bank account I am depicted by the double ellipse. This is double rectangle, not double ellipse, double rectangle. So double rectangle symbol used to represent the weak entity. So in a bank account, in a bank, I have my bank account, no issue. But I can have the many account. So when I have the many account, but in my account I have, but I didn't get the account number. So what I can say, a customer can have the many account without any account number. So if I have the many account, so I can open the many account, saving account or FD account or other details. But in the my diagram, if I'm not depicting the account number part, I'm just depicting the account type what I have. So in a bank, I can have the many account. So it means I was talking about the account type, saving account or current account. So suppose I have the 5 saving account in a bank. So that is possibility I can have. So same person can have many accounts. But in this case, we can't say account number we are not using to describe the our ER model. So what happened, such entity can be identified by the big entity because there's no clarifying I have the one saving account or I have the 5 saving account. So that IR diagram will not clarify the statement. That is a point. So an entity that cannot be uniquely identified by its own attributes, so such entity is known as the weak entity. In a university, I'm connected to the student data, student entity. So a student can be the big entity when we are not depicting the information by the student roll number, because I'm not used to using the student roll number attribute. I'm using student name and student age and student date of birth. There are many chances many students can have the same name, same date of birth, and same age. Yes, of course, it's possible. So at the time, such entity is known as the big entity. So at the time, to depict that part, we have a double rectangle. Now, is it clear to all right now? Now, this is clear?
Yes, sir.
Okay. Now, strong entity will be the reverse while applying the key attribute. So now automatically it becomes the our strong entity, nothing. And there is no special symbol for the strong entity. By default, what is the single or simple rectangle box I'm using? That is the strong entity. Now attributes. Attribute will be represented by the oval symbol or ellipse symbol as we have seen. So we have a 4 types of the attributes. One is the key attribute, composite, multi-value traits. Let us discuss the one by one, and I will show the example with the help of the simple concept, so everything will be clear to all. Now, key attribute. Is it clear to all right now? It is clear to all right now?
Yes, sir.
So what is the definition? It is written over here. A key attribute can uniquely identify an entity from the entity set, uniquely identify all the records. So that attribute which defines all the data with in the uniqueness. So we have. So a good database must have a strong entity. The strong entity I am using the student, while I'm just adding one more point, that is the roll number. So when we have a key attribute, we are using the strong entity in the ER model. Name, age, and address could be the common, and name, address, age can be the common or can be duplicate, but roll number cannot be duplicate at any cost. And that defines the uniqueness in the our part. So in the BAI, suppose in the 19 BAI, same student name, same age, or same date of birth student I'm finding, but I'm not using the 19 BI or 20 BI. So how I can say the student belong to the which year? Is it 19 or is it the second year or third year or first year? I don't know. That is the reason. Sometimes students call me many times, sir, you were the part of my previous course, so we got a great chance to learn something from your side. So I replied, can you tell me in which course you were part of my student? Because I am just having seen the contact number, I am not able to understand. You were the part of the one 19 mm, 19 BI, or 20 BI, or 20 mm. So he said, sir, I was part of the 19 mm. So that was the reason I can understand easily. So duplicacy can be. So to avoid the duplicacy, you can put the key attribute to identify your record or data in the Unix. So that's why we have the key attribute. And key attribute is, you can observe in the ellipse or oval, we are underlying the name of our attribute. Is it clear to right now? You can easily say, is it clear?
Yes, sir.
So roll number is underlined, so that is the point. So this was our key attribute, so we have discussed. Now, composite attribute. As I told you many times, address is another example. So student is our entity, and that is connected by the address. So student is having the one entity right now. I'm just showing only the partial part of our ER model. So address. So in address, we can have the many parts. What are the part? PIN number, okay, state and country and area, and city could be. So name is also another example. First name, last name, and middle name. So this is what this is known as our composite attribute, and we can transform such part over here in our table. So address can be identified by the 3 different columns, and these columns could be the part of our state our address column only. So that is the point we have to understand. Now, the composite attribute is clear to right now with having seen this diagram. Is it clear to all?
Yes, sir.
Address, the CA is written over the address that defines the composite attribute. Now, let us move to the next attribute, multi-valued attributes. As a student told me, sir, address is the 2 type of the local address, permanent address. So yes, definitely. Having heard the answer from the student, I have already done the local address, permanent address could be the multi-valued attribute. So when we have the multi-valued attribute, so that is known as, that is to be depicted by the double oval, or we can say double ellipse. So multi-valued attributes, we have example, your contact number, mobile. Yes, of course. Contact number can be identified by the 3 different parts, that is the country code, area code, or actual phone number. And the mobile number, we have the 2 parts, one is the country code and mobile number. So with the help of that part, we can easily identify our contact number. So suppose I found over here in my contact list, I found some numbers are not belong to the 10 digit. In India, we have the mobile number 10 digit, but I found some mobile number not belong to the 10 digit, but they are valid. So I can understand this is not this country mobile number. This could be another country mobile number. So by applying the country code, I can easily call the person who need to talk to me. So definitely we can have this one. Yes, this is and this can also identify by the another example as a student told me. So I have already depicted the information over here. Phone number. Yeah, 2 phone numbers you can also have. One is your phone number, own phone number as well, and your parents' phone number. So when I need to communicate to your phone number was switched off due to the another reason, maybe battery goes down, and I can easily call you by your parents' call. Can I speak to the XYZ student? So your mother or father will hand over the one mobile to you, and we can communicate to. So definitely we have this chance to talk. So this is what is a multi-value attribute. So when we have the multi-value of the such attribute, that is known as the multi-value attribute. So is it clear to all right now? Having seen the example, having seen the diagram, a theoretical point, is it clear to all right now?
Yes, sir.
Now, third or fourth one, we have drive attributes. And drive attributes is depicted by the dashed ellipse, as I told you while discussing the symbols or notation of the year. So you are getting your age from your date of birth. So age is depend on the date of birth. So when we have the age is depend on the date of birth, so age becomes the drive attribute from the date of birth. So you can see, observe over here the student phone number, which is just highlighted by the double oval or ellipse. That is a student phone number can have the many values. Many values means many phone numbers. Student name I put it over here, no issue. And drive attribute is just that is we have the drive attribute that is marked by or that is depicted by the dashed ellipse, which is described as a drive attribute. And date of birth we have the normal attribute, so no issue. But while seeing the student ID becomes our primary. We can say key attributes. Student ID we have the key attribute, so definitely such entity student becomes our strong entity. Okay, so now clear? Is it clear to all right now? This is drive attribute will be depicted by the our dashed ellipse only or dashed oval we can say. Now clear?
Yes, sir.
And another example, you can take your grade or your CGPA is depend on the number of how many grades you are getting in the all the courses. So in the 5 courses, what is the grade you are getting? So your CGPA will be calculated automatically from the grade. So CGPA column or CGPA attribute becomes the drive attribute based on the different attributes. That could be one kind of the example. So is it clear to all about the attribute is clear to all? So these 4 types of attributes clear to all? Or any doubt so far you have, so please you can ask me right now. Yes, tell me right now, any doubt?
No, sir, no doubt.
Okay, good. So this is the example I put it over here to explain my idea. So the previous example in the previous slide I have explained in detail. Student ID becomes the key attribute, student name and student phone number as the multi-value attribute, and the drive attribute we have the age and this one. An address was not attached to the my part. So what I did, address was not mentioned in the diagram. So what I did, I added the address attribute over here, and address definitely becomes the composite attributes. So you can see I'm expanding the address attribute, that is compose attribute, followed by the area, city, pin code, state and country. So expanding the details of an attribute into its sub attributes is known as a composite attribute. That is a simple definition I can say. So this is the diagram which describes the attribute and entity type. Now it is clear to all right now. This is this diagram is summary of the our discussion points so far we have discussed. Tell me right now, any doubt so far?
No, sir.
Oh, you have a doubt, you have a no doubt. You don't have any doubt or you have any doubt?
Sir, no doubt.
So having seen this components part or having seen the different types of attributes, I hope now you have some confidence to build your own AI model based on the problem. Just tell me right now, are you able to build your own model or AI model by seeing the problem? Just tell me right now, are you able to build? Now you have the confidence to build your AI model having seen the problem or having seen all the situations. Okay, now at least you have some confidence. That was my point. But no problem. I will share some exercise and just you have to understand the exercise and you have tried to draw the ER model. So all the things I'm drawing over here. See, I have updated the ER model which is mentioned on which is drawn in the previous slide by adding the composite attribute. So now this is our example in which we have the one entity only. An EI diagram can have at least one entity. But here I'm not using the relationship type. Why? How I can make the relationship? Because no other entities are available over here. That is only the point you have to understand. So now let us understand this one. This is the example I'm discussing over here. So is it visible to all right now?
Yes, sir.
Okay, so while discussing this point, ask me the question. So based on the question, I have depicted the example over here and to show my proof. See, customer is visiting a shopping mall and he need to purchase a product. So many customer can purchase the many products. So you can see I have written MM. So MM means the many customer can purchase the many products. So this is relationship type we have. Key attribute of the customer, we have the customer ID, customer name, we have address, we have. Address have expanded by the city and pin code, so that is a composite attribute becomes. And contact number, so contact number becomes the our multi-valued, so that can have the many contact number. A customer can have the many contact numbers, so I put it over here. So all the attributes, those are the customer number, address, customer name, and city, customer ID becomes the attribute of the customer. And what are the other two components? Suppose these are the some regular customers, so we can wish on the birthday, or we can celebrate the birthday of my customers who are the part of my shop. So definitely by date of birth we can put the details, and we can also put the age. So age of the customer will be calculated by the date of birth. So when the current date of the, or we can say the date of birth date is fluctuated on the my screen, so we can send the message to the respectively customer to celebrate a birthday, just like any message, celebrate a birthday, today your birthday, so I wish all the best, and so on. So message you can put. So that is the customer entities, and that is the customer attributes. A product ID becomes the key attributes, and product name and amount I have. So when a customer or many customer want to purchase the many products, so what you are observing over here, purchase is our relationship. Purchase becomes our relationship. Okay, is it clear to all right now? Is it clear? Purchase becomes the our relationship type. So customer purchase the product, so many customer can purchase the relationship. So that is the point you can observe over here. The customer has to purchase at least one product. So rather than the putting a single line, I have drawn the double line from purchase to the product. Is it visible to all right now? Is it visible?
Yes, sir.
And that is the total participation, which describe that customer is coming to the shopping mall or the my shop, at least he will purchase the one product. So that is why I'm putting the total participation. But in sometimes I found some customers are just coming in the my shopping mall for round purpose only. They are not purchasing anything. So I can remove the one line. I can keep the one line from purchase to product. So at least I can say there's no guarantee in from my shop customer will purchase. But when my shop, if customer is coming, so at least he is purchasing at least one product, then I have to put the double line, that is the total participation I was discussing. So that's why I have written the statement, customer has to purchase at least one product if he is coming to the my shop. So I have to use the double line rather than the single. That is the total participation symbol. Now, is it clear to all right now? Tell me, is it clear?
Yes, sir.
And I have, customer are not coming to the shopping mall to purchase the product only. He can move to anywhere. So after purchasing the product, this customer is moving to second floor, third floor to have some bite of the pizza or some sip of some different cold drink. So if he is moving to the different floor, so floor is become our entity. So I'm not putting over here the floor ID or floor number. He can move anywhere. So just example I'm taking only. The floor name and the number of the shop, what number of shop we have in the floor. So I have given the name of the floor name and number of the shop. Only nothing else. As we know, we can have the ground floor, first floor, and second floor. That would be unique. But suppose we are assuming only. We are not using the any ID. We are not keeping the any uniqueness in the record. So because customer is coming to ground floor, then he is moving to the first floor, and then after some time he is moving to ground floor once again. So duplicacy can be happen. So I am not putting the any key attribute, or I am not attaching any key attribute to the floor. So I am assuming this floor entity becomes a big entity. So I am drawing by the double ellipse. Now is it clear to right now? And what is the relationship between the customer and floor? The moving. He is just moving or he is just going. So I've just put the name of the relationship and that is moving on. Now, is it clear to all right now?
Yes, sir.
So this is an example which describes the entity relationship diagram model in simple way rather than the book. You can go through the books and you can find all the attributes, all the things, but I have explained the thing with the real life situation, a real life world. So in my teaching methodology, you will find I am always connected to my student with the real life problem, so they can easily understand what is really happening. I can take the example of the university. I can take the example of the any automobile shop. I can take the example of the bike servicing. Okay, if I need to go to the bike servicing, I can go. So what is the entity? My bike as a my customer. So I have the two entities. And after reaching the service center, so service center becomes another entity which can have the many things. So there are the connection I have to establish. I have to make the relationship based on the some attributes. So what, how I can mix? That is the point you have to understand. Now it is clear to all right now. I am taking the simple example. Now tell me right now, is it clear to all?
Yes, sir.
Yes, sir.
Oh, yeah. Okay, good. So now come to the point relationship. So this is the when we have the point that is identified by the diamond shape only. So we have seen the one-to-one, one-to-many, many-to-one, and many-to-many. So without wasting the much time, I'm just showing the example only. One-to-one relationship. A person has a one passport. Do you have a right to have the multiple passport? If you are doing, then you are doing the illegal activity. So as a being a Indian origin person, I can have only the one passport. It doesn't mean it's a different case. You can have the two passport. Depends on the what is the you really have the flexibility. It depends on the cases. But being a normal person, I can say I don't have the multiple passport. I can have only the one passport, either of the this country or other country. I can have the multiple passport. That is a different cases. So I'm not discussing the cases, but logically I can have the one passport. That is the one to one. Now one to many. One faculty can teach the many students. I told you many. One faculty can teach the many students. So that is the one to many. As a customer, I'm the customer. I'm visiting the Domino Pizza. I'm ordering the one pizza, and next time I found okay, it is very tasty and delicious, so I can order the another pizza. So as a customer, I can order the many pizza. I can order the many cold drinks. So that is what? That is a one to many relationship. Now many to one college can have the many students. One faculty can teach the many students. So so many students are taught by the one faculty. So depend on the direction from which you are reading. So many students are taught by the one faculty. So this is a man-to-one relationship. And many students are studying in one college. That is a man-to-one relationship. That is a simple example. And many to many. Students are worried about the assignment. As a student, you are getting the assignment from my side. As a student, you are getting the assignment from the other faculties as well. So in the 5 subjects you are teaching in this semester, then what happened? 5 faculties are giving the 5 different assignments. So 5 into 5, 25 assignment you are getting in a semester. So what happening? Many students are getting the many assignment from the many faculties, and there you can be involved in the many projects as well. So this could be the relationship of the many to many relationship. Okay, so now it is clear to all the many to many relationship type, many to many, many to one, or one to one. Is it clear to all right now? Tell me.
Yes, sir.
Okay, good. And total participation, I am speaking once again over here. I am just rectified the diagram as we have seen the few minutes ago. Total participation of entity, that means at least one data should be there. So customer place the order. If I visit a Domino and I'm going inside the Domino shop, and after that I'm coming back, so some people are laughing me. Oh, why you are coming in this shop? You have occupied the seat unnecessary. Other persons, other customer are waiting outside. So after reaching the Domino, I just look at my pocket. I don't have the budget, but see, I have occupied the seat, so I have to at least order the one pizza. So the relationship between the order entity and customer entity, we have a total participation symbol, that is a double line. So at least I have to make the one order. I have to place the one order. So that is identified by the double line. So here in this case, if I'm opening a college, I got a great chance to open a new college. So if there is no student in my college, so what is the sense of opening the college? So in my college, there is a one student, so we can say at least one student is studying in the college campus. So that is identified by the total participation. Now, student ask me the question. Now, is it clear to my dear? Tell me right now, total participation concept is clear? Someone asked the question, that's why I'm saying. Is it clear to right now?
Sir,
So total participation of an entity set means a compulsory relationship between two entities.
No, there is no, see, some students and college, I'm not putting the total participation. So we have a statement, many students can study in the college or can, in the college, many students can study. But there is no guarantee, there is no guarantee. We are founding, there is a zero data we have. We are making the relationship type, that it doesn't mean. But we are, at least we can say there is there is no guarantee. But after applying a total participation, at least we can say one data will be there. At least one student will be there. One information will be there. So same I'm speaking. There will be relationship between the you and intern semester, but you have not opted the any courses so far. So how you will face the exam intern semester? There is no chance. But there is a relationship between the you and intern semester, and as coordinator will call you many times based of the courses, but you are not opting. But there is a relationship between you and intern semester, but there is no guarantee you will opt the course. But at least it is forced by the FCS coordinator. You have to choose at least one course. So that is what you are applying the total participation on your at your level. So what you are choosing the at least one course to face the intern semester exam. So here we have a total participant. At least in the at least what information will be communicated with the relationship. So we have the at least one relationship to define the one information that we are getting from the data. So there is one guarantee at least. So our one information will exist in our relationship. That is the point. The total participation means defining the one at least one relationship. A relationship value will be exist when we have some data, but we don't have any data. So what, see, I'm open the campus, I'm opening the college, and there is no student. So what is the relationship between the student and my college? No relationship, because there is no student in my college. And after the 4 years I found there is no student, so there was no relationship between my college and my students. But I am observing at least one student is studying my college, so I can say uh, we have a relationship between the student and college. That was my point. Now clear?
Yes, sir.
I can rectify my justification properly. So you are going to again visiting the Tropino shopping mall to visit the just for the time pass purpose. But after reaching the inside the or just occupy the seat in the Domino shop, then you are sitting. Then just waiter or the person is coming. Ask you, sir, which kind of the pizza you would like. But you are not making the order. So what is the relationship between the order entity and as a customer you? No, don't relationship. So relationship will be exist when you are making at least one order. After placing the one order at least, now you come back to the home, no issue. That is the point. But after you are placing the many orders, so there will be no issue. But at least you are making the one order. So what we can say, there is communication between the entity and relation. At least we have. So we have the one data by which we can. So that is my point. At least we are making the one order. At least one student is exists in the campus. That is the point. Now clear? Clear? Or should I take one more example? Yes, tell me right now. Yes, tell me right
Sure.
now. Yeah. Okay, good. So, in a short way, I can tell the advantages part and disadvantages part. So, what is the features of the year model? I will take hardly 2 minutes more. So, just give me 2 minutes more. Just describe the so far what we have discussed. The feature of the year model, the graphical representation for better understanding, of course. And ER model, we are using visual tool. And database designing. So database designing means we can design the database along with the properties by which we can use. So feature of the ER model, it means the graphical representation. We have the graphical, we can understand what are the entities we have, what is the database we can have, and what are the attributes or what are the column we can have. And with the help of the visual tool, visual representation, we can see the or we can understand the thing in simple way. And database designing will be easy. Just transform all the entities into the tables and column and attributes into the column. So we have the thing. And while seeing the key attribute, we can make our entity or column as a foreign key or primary key. So this is our concept. Now, the advantages are, we have seen many times, simple, effective communication tool, and easy conversion to any model. Yes. So it is very simple. Yes, definitely it's graphical, it would be simple. Effective communication tool, of course, with the help of the various notation, we can say it is effective communication tool. No need to understand anything, just use a symbol and notation and we can easily understand. So having seen the understanding, easy understanding, it is more convenient to understand our component or other logic. So we have the effective communication tool. An easy conversion. We can transform this ER model into the relational database or any other model. Just we have the graphical data. So if you have the graphical data, we have graphical information by which you can transform in any form. Yes, of course, it is possible. Unlike transforming your flowchart into the algorithm or any other logic, you can change. You can transform. But this it has also having some drawback. So drawback we have the, if you don't know the syntax, if you don't know the notation of the our ER model, then you will not able to understand what is happening inside our ER model, just like total participation. So without explaining the total participant, you will not bother about the, you are not able to understand what is happening by the total participation and why the two double lines are used, why double dash I'm using, or the double ellipse I'm using, or double ellipse I'm using. You don't know. So you need to understand the some meaning of the notation, and these notations are not defined to the industry, because any industry is not occupying all these things, because every time you are not able to understand this notation. So some training are required, but these are not standardized. But it is mentioned, it is defined by the organization. So I'm using only those parts. But any industry, there's no standard tools and there's no standard definition I'm using to define the thing. So there was no issue, but now every industry is in today's era is opted this one. So this statement is not much valid nowadays, because every industries are easy to understand by the help of the various tools. Now this notation are standard. But previously it was mentioned in the 20 years ago, no industry standard for the notation. But now this has been changed. In some hidden are information are hidden. Yes, definitely this is the point. Just like the composite attribute. So if we don't know the address, so address we have to identify. Address could be the permanent address or a temporary address. An address can have the various part. So that is something will be hidden. We have to assume, we have to identify. But that is the important point we have to understand. So while using the composite attribute, many times we will shun. We will shun means we can prevent to use sub attributes. But very frankly speaking, we have to use. So in a room I'm using. So in a room's number of the windows. Number of windows will be by default. So we have to identify how we can expand, how we can identify the information. And some information will be hidden. So this is a point we have to understand. But now disadvantage are over. Yeah, I know.
It's already